Just in terms of the basic ideas for measurement, there are some important words you need to be aware of. There's the word of perimeter, and there's the word of area. And then there's also later on the word volume. There's sort of, when we talk about area, there's also another word that kind of goes with that called surface area. So these are three ideas. You need to know what these things mean. And then we also deal with particular shapes. So we deal with triangles, different types of triangles. So we have acute angled triangles, obtuse, we have right angled triangles, we have rectangles that we need to know about, we have squares and various types of quadrilaterals, and then we also have circles. And then we can also make combinations of these shapes. So these are the main ideas that we need to know about. Now, when we talk about perimeter, perimeter just means when we go around the outside of the shape, like that. So that would be the perimeter of a shape. If we talk about the area, it's how much space fits inside the shape. Okay? So that would be area. And for surface area, let's see if I can do this. Surface area relates to three-dimensional shapes. So this is a square prism. If we talk about the surface area, we talk about the area of almost the wrapping paper on the outside. So if we went around the outside and we added up all the surfaces, and this side here, what would that be? And then volume is just for a three-dimensional shape. How much space actually, in fact, let me take this away because it's actually misleading. So surface area is like taking that, adding up all the blue bits, adding up the red bits there, and then adding up, let's say, all the green bits there. That would be the surface area. It's like the wrapping paper on the outside, whereas volume is like how much stuff fits inside of this three-dimensional shape. Give me a thumbs up if the words perimeter, area, and volume, surface area, and these shapes make sense to you. Give me a thumbs down if you're feeling a bit like I'm going too fast and I need to do some groundwork. And remember, you need to vote honestly because I read your emoticons like I would your faces. Okay, now, before we get started, there are some important formulas that we need to be aware of. So I'm actually just putting them down. Boucle, you said, so I didn't quite hear. Let me go and look. Sir, I didn't quite hear volume. Please re-explain. So volume is just how much stuff fits inside a three-dimensional shape. So let's say I have a cylinder, which is basically like a can of Pringles. It's basically like how much stuff will fit inside of this three-dimensional shape. Does that help, Boucle? Give me a thumbs up if that made sense to you. Okay, now in terms of the formulas that we need to know about, probably the area of rectangles, so we talk about the area of a rectangle, that's just going to be length times breadth. That's not particularly hard, so that's fine. We also need to know about the area of a triangle, which is a half base times perpendicular height. And then for the area of a circle, we get pi r squared. So those are the big three. Again, give me a thumbs up if you are comfortable with these three area formulas. Give me a thumbs down if you're like, just clarify. Like Boucle asked a question. If you have a question, just pop your hand up or put it in the chat, and then I can assist you. Okay, so I'm assuming we're okay with that. Just to remind you, in a circle, when we talk about r, r is the radius in a circle. Now, there is a special word that I want to mention, which is the perimeter of a circle. What is the special word for the perimeter of a circle? Pop it in the chat if you know what it is. Okay, so the special word for the perimeter of a circle is the circumference, yes. And there's a special formula that we use for the perimeter of a circle, and it is just diameter times pi gives you the circumference, or we say the circumference is 2 pi r. This is an important formula for the perimeter of a circle. Now, later in this unit, we will talk about more exciting three-dimensional shapes, but I don't want to go too far ahead. For now, I'm going to keep the three-dimensional shapes anchored on rectangles and circles. Okay, let's get cracking. So very first question, a nice easy warm-up one. What is the perimeter of this shape over here? What is the perimeter of this shape over here? Pop your answer in the chat. I want to see some numbers, ladies and gentlemen. Welcome to Alexa, Bukle, Callan, Ganlon, Machadiso, Naleri, Njabulo, Untakeni, Oratile, Pabelelo, Pila, Reniwe, Tamia, Tenda, and Busile. Welcome to class today. Callan, I agree with you. In a we basically know it's 15 plus 15 plus 5 plus 5. It is 40 centimeters. Okay, what about area? You figured out what the perimeter is, which is the yellow thing. What is the area of this shape? What is the area of the shape? So the area is length times breadth, or 5 times 15, and you get 75 centimeters squared. Now, what's important is the units are different for area than perimeter. What this literally means is there are 75 little squares that will fit inside this rectangle. So 75 centimeters squared, there are 75 1 centimeter by 1 centimeter squares that fit in here. Okay, important to notice the difference in units. Okay, let's go to the next question. This one's a bit more exciting. I want you to find me the value of x. And they tell you what the perimeter is in this thing. What is the value of x? Think of these questions as stretching questions. We're just getting in the mood for measurement. Okay, I see you're on form today. So I would add up 3 plus 5 plus 10 plus 6, which is 18, which is 24. But now I need to go 30 minus 24, which is 6 centimeters. And that's what this must be, 6 centimeters. Okay, now for bonus points, should I make it for bonus points? Can you find me the area of this shape? Can you find me the area of this unusual looking shape here? I can probably color that in a bit better. Let me try again. I want to know what is the area of this shape. Maybe someone can give. Oh, Naledi's asked, sir, please explain how we got 6. So, Naledi, what I did was I added up 3 plus 5, which is 8. Then, let me actually take this away. So, I took 3 plus 5, which is 8. This is 18. That's 24. So, the green things give me 24. But it said the perimeter of the shape is 30. So then I go 30 minus 24, which is 6, which means that's what this bit here, the yellow bit, has to be. Did that help, Nelly? Perfect. Thank you for your question. Now, I think students are finding this next bit much harder. Can somebody give us a tip? Either turn your mic on or give us a tip in the chat. What strategy would you use to help find the area of this shape? It feels like a combo shape. Sunday has given us some very good advice. A square plus a triangle. I think that's fantastic advice. Kwande has said the same thing. I should divide this up. Oh, that makes it so much easier. But now, I don't know. Okay. I'm going to suggest that this thing here is 3. Because that is that. I need to know what this length, the green length, is. And what I'm going to say is, by the theorem of Pythagoras, this has to be 4. Give me a thumbs up if you remember the theorem of Pythagoras, which says that the hypotenuse squared is equal to, okay, so that's 4. Now, can you work out the area of this shape? Can you work out the area of this shape? So, I think that this bit here needs to be 6. Oh, oopsie daisy. This needs to be 6 because 6 plus 4 gives me the 10. My square is 6 times 6. So that's the square bit, but now I need to find the area of the triangle. So that is going to be a half. Now what's the base? It's 4 times 3. So the square is a 6 by 6 square, and then the triangle is a half times 4 times 3. Give me a thumbs up if you understand my working. Thumbs down if I've lost you, or make a comment. Okay, I've lost a few of you. So let's just have a look. If I look at this bit over here, this blue bit is the actual square. And the reason it's a square is we figured out that this was 4. And what's 10 minus 4? It's 6. The 10 is for this whole length here. Now this is 6 by 6 by 6. So this must be 36. And then the area of the triangle is a half base times height. So that's 6. So you're going to get 42 centimeters squared for the area of this shape. And let's see, we are in the house. Thumbs up if you got that. Thumbs down if you didn't. I need a quick vote from the class. Naledi, oh, is that, oh, there was a thumbs up. Don't worry. Okay. That was a good question. I like that question. We are learning. I can feel it. Okay. Find me the perimeter and the area of this shape. Find me the perimeter and the area of this shape. And if you've got tips for the class, give us your tips in the chat. Like, if you know how you would find this. Love it. Love it in the chat. Love it. So it's Kawe and Callan have said use Pythag. So we shall do that. And we have 15 squared must equal 9 squared. I'm going to make this x. And we use that reason. And someone can help us in the chat with getting the area, when getting the x. What is the x value going to be based on your calculation? So we are getting an x value of 12 centimeters. So then the perimeter must just be 12 plus 9 plus 15, which is 36 centimeters. What's the area of my triangle going to be? So remember, for a triangle, it's a half base times height. You have to decide what the base is. Or the base could be either this or that, as long as it's with the right angle. So I'm going to say 9, then times 12, which gives, what is that going to give us? 54. 54 centimeters squared. Okay, so that when we talk about the area, it's how much stuff fits inside the triangle. But you must always use, for the area of a triangle, half base times height. Or, okay, remember back when we did trigonometry, there's also something called the area rule, which is half times the length of one side times the length of the other times the sine of the angle in between. But that's, yeah, you only use that if you have to, I guess. Thumbs up if you're ready to move on. Thumbs down if you're feeling like I'm going too fast. Okay, so I want you to find me the perimeter of this semicircle, and I want you to find me the area. And I'm going to give you 2 minutes to do that while I go and get some water. So it's a semicircle, not a full circle, and they've given you a radius. You need to work with that and see what you can get. What are we getting for our perimeter of our semicircle? So I'm pretty confident that the yellow must be 7 because it's just this and this. But now I need half of the circumference. So if we remember, the circumference is just diameter times pi, or it's 2 pi r. Both of those would work. I'm just going to use this one. So it's going to be 7 pi. So the circumference, the full circumference is 7 pi, but I only want half of that. So what is 7 plus 7 pi over 2? let me try and do this. 7, and then pi, you go shift, and then the bottom at the bottom, and then divide that by 2. I am getting, see if you agree with me, I am getting 17.995. So actually, that would round off to 18 centimeters. I see lots of people have different answers. Maybe I've made a mistake. Have I left something out? So diameter times pi would be the full circumference, right? So that would be the full circumference, diameter times pi, or 7 times pi. But now I divide it by 2 because I only want the green bit. So I'm feeling pretty confident. Who got 18 centimeters? Who understands? Can you work out as normal and then divide by 2? Yes. Okay. Let's do the circumference first. So we go 7 times, okay, I've lost lots of people, so let's slow right down. Are we happy that the yellow bit is 7? Can I have a thumbs up or thumbs down for the yellow being 7? Okay, people are with me. Okay, now I need to get this green bit. Now, this circle here has a diameter of 7 or radius of 3.5. If I want the circumference of the circle, it's just going to be diameter times pi, which is 7 times pi, which is the same as saying 7 pi. The problem is you've now got the whole big circle. So instead, for a semicircle, the circumference will be 7 pi divided by 2. Give me a thumbs up if you are following me with the green stuff. Okay, now to get the full perimeter of the shape, remember the perimeter, this bit doesn't exist. The perimeter is the outside of the shape. So it's this and that. So I'm going to add on my calculator 7 plus shifts pi times 7 divided by 2, and I'm still getting 17.995, which is 18. Can you give me a thumbs up if that now makes sense to you? Well, I'm so glad that I could help. This is the benefit of asking questions and giving clear feedback. We can all be on the right path. Okay, let's do another one. Let's do this one over here. I want you, let's start with the perimeter. Let's start with the perimeter. Forget about the area. I want you to find me the perimeter. And all I'm going to do is I'm going to highlight with colors a little bit of a helping hand to help you out here. I invite questions. I'd love an audio question if someone put their hand up, but I understand sometimes that's tricky. But you try and find me the perimeter for this. I call it the ice cream cone. It looks to me like an ice cream cone. Yes. Bukle, what is your question?
So I just wanted to ask, when calculating the perimeter, do we have to calculate the diameter first then? We can't just use radius.
Okay, it's a good question. So if we think of the pink bit, Bukle, we're going to use the same trick as before. So there's two choices. You can either use the circumference as 2 pi r, in which case you could really just do that. But remember, that's the full circumference. Or you could double this, 8 and 8 is 16, and just go 16 times. So you could use this one over here, but you'll see it doesn't actually make a difference. So diameter times pi, and then you'd get 16. So both of these would give you 16 pi, but there's one important thing I've forgotten. 16 pi is not the pink bit. The pink bit, the circumference or the semicircle circumference, is going to be 16 pi divided by 2, which is 8 pi. So that is the pink circumference bit. Now, I need to figure out this blue stuff. Now, I'll give you another thing. This has to be 8 because this is a circle. So this is radii. How are we going to figure out these turquoise parts? What do we need to do? It's again, it's our friend Pythagoras. All the time in measurement, Pythagoras often will link things together. So you always have to think about Pythagoras getting involved here. Okay, so I know this is 15. I know this is 8. By Pythagoras, I'm just going to call this y. Y squared is 8 squared plus 15 squared, and I state the fact I'm using. Who can help me with a y value? Who can help me? Naledi, can you help me? Maybe into Kenny, you can help me. Oh, Sunday, there we go. 17 centimeters. Is anybody else getting 17 centimeters? Thank you, Kilabukile. No problem, Naledi. So now I want to know what is the final answer for the perimeter of the ice cream cone. What is the final answer? What do you think, Pilar? I guess I have to do this, 8 pi. I need my calculator, so 8 times. What are you getting for your perimeter? I'm getting 42.13 centimeters. Give me a thumbs up if you're with me. Am I making a mistake? Let me try again. 8 times pi is 25.13 plus 17, 42.13. Yeah, that is correct. Okay, before I want to take a break, but I'd really like to get the area. So, last question before the break, the brain break. Find me the area of the ice cream cone. So, you're going to find me the area of the yellow bit, and then you're also going to find me the area of the green bit. That's the tip I'm going to give you. You need to work out the area of the ice cream cone. Let's do it, ladies and gentlemen. Calendars asked, sir, why are we using 17? Oh, I've just realized I've made a mistake. Callan, I left out the reason we're using 17 is, but there's actually 2 17s. So I apologize. You see, this is why students are so good at asking questions. So let me recalculate that. I left out one of my 17s. I was trying to do too much. Plus 8 times pi. So I now get 59.13 centimeters. Callan, let's go to you. How can I help?
So I was asking why we're using 17 because in class don't we in general don't we use the middle part to calculate perimeter instead of the sides,
It's a
or is
very
it
good
just
question.
me?
Okay. The word perimeter must relate to the outside. So the 15 is the middle one. It'll become very useful in the area calculation. But for the perimeter calculation, we need these outside blue sticks and then the pink bit here. So we had to use the Pythagoras calculation, 8 squared plus 15 squared, to give us the 17 on the outside. Does that help, Callan? Do you understand so perimeter is strictly like you're walking around the outside of the ice cream cone. The next step, where we find the area, your 15 is going to be very helpful. So just give me a thumbs up, Callan, if that makes sense to you now. It was a great question. Awesome. Guys, you're asking such good questions. Let the questions keep coming. Let the people speak. So, Naledi, for half a circle, the area of a normal circle is pi r squared. So to get half of it, you just go pi r squared divided by 2. So let's see. To get the area, I need this plus this. What are you going to get? I like writing in my formulas with space for the stuff that I'm going to fill in. I find it very helpful. So what needs to go here? It's pi r squared, but it's actually going to be pi r squared divided by 2. So watch out for that. And the r is 8. So the r is 8, but I need to have the divided by 2. And then for the triangle, it's a half base, but the base is going to be this whole thing here. And the height, and this is what I was talking to Callan about now, the height is going to be this thing over here, which is 15. So I've got half a circle plus a triangle. What are we going to get for our final area of the ice cream cone here? Okay, so in my calculator, I'm going to go shift pi times 64, or 8 squared, divided by 2, plus, and I get 220.53 centimeters squared. So there will be 220 little squares that would fit inside the ice cream cone. And I see Pila and Naledi and Callan all agree with me, so this I'm feeling confident. Okay, everyone, I've pushed you a bit far today. We need to take a brain break, so I want you to step away from your computers, and I want you to stand up with me. We're just going to take a quick break, and we're going to take 3 deep breaths. Breathe in. Breathe in. Breathe in. And then shake out your arms to get them nice and loose. We want to get some circulation. Shake out the arms, shake out the legs. So shake them out. And you should feel some nice circulation and relaxation. And then just to get your brain awake, we're going to do 15 jumping jacks. This is what a jumping jack looks like. And we will start in 3, 2, 1. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ooh, and now I can feel my heart is pumping. So just take 30 more seconds to let your heart catch up with you. Mm. And then while we do that, while we're waiting for our heart to catch up with us, I just want to talk to you quickly about boot camps. So if you haven't signed up for our exam boot camps for term 4 yet, there is still time. And if you want us to contact your parents, you can just fill out the form that I'm going to put the link to in the chat. Let me do that now. So in the chat, I just put the basically book your spot form for the boot camp on the weekend. And just to explain, in case you don't know what boot camps are, they're extra lessons on Saturdays in the run up to final exams. And we also provide you with old papers and extra work that you can work by yourself. But we meet from 2:30 to 4 p.m. on Saturdays for the next 3 Saturdays in the run up to finals. And our first one is starting this week, Saturday. I'll just show you the little promo thing that I showed at the beginning of the lesson. So if you want, you can also take a screenshot of this little thing. And if you want us to contact your parents, you can also fill out the Google form that I just put the link to. And yeah, that is just to promote the boot camp so that you know it's happening. There will be a separate Google Classroom for the exam boot camps. Okay, let us get back to what we were doing. Where were we? Okay, so I think you guys are getting a hold on area and perimeter. So let's just have a quick look at some more theory that we need to think about. So I mentioned this earlier in the lesson, but when we think about area, the squares and the rectangles are quite easy. It's just side times side, essentially. But when it gets to triangles, things get a little bit more exciting. And you need to remember that the base is always going to be perpendicular to the height. But the height for a triangle doesn't need to be inside the triangle. Like if you have what we call an obtuse angle triangle, the height of this triangle is actually outside the triangle like that. Okay? But if you wanted to find the area of this triangle, you would need to find the length of that blue side, and then you need to find the length of that height. And you'd go a half base times height, where the base would be that bit and the height would be that bit. And that often catches students where the height is outside. Give me a thumbs up if that little tip makes sense. Okay, we're just kind of doing a recap of important ideas from grade 9 and 10 today. Then, if we have something called a parallelogram, the good news is all we need to do is go base times height, although I like students to say base times perpendicular height, so they don't forget that the base and the height are perpendicular to each other. So a parallelogram, you know, essentially, and so is a rhombus, and all these ones are just base times perpendicular height. And then for the trapezium, all we need to do is look at the parallel sides. So these are the two parallel sides in a trapezium. We add them together and divide them by 2, or add them together and times by half, and then just multiply by the perpendicular height in the same way that we do it here. And then the one that we've done already, the area of a circle is just pi r squared. But obviously, if you have a semicircle, well, then the area will be pi r squared divided by 2. What if we have a quarter circle? What if we have a quarter circle? What will the area be of a quarter circle like this? Who feels like they can figure that one out? I think you all know that all you need to do is say the area of a circle divided by 4. Okay, so those are the basic area formulas that we need to keep in mind. We've done some area questions. Let's go find some more. We've done that one. We've kind of done. Should we do this one? Okay, let's just do this one. So you are going to find me the area and perimeter of this shape. So let's start with the perimeter. Now, just to point out what the perimeter is, the perimeter is this over here. But you are only given 2 pieces of information. You're told that this is 600 over here. So you're told that that's 600, and you're told that this is 400. And you need to work out all the other bits and pieces. So off you go, figure out for me the area, sorry, the perimeter of the shape. We'll get to area after this. I will say there are these rather handy little whiskers, which mean opposite sides are equal when you see these lovely little whiskers. I guess I can write this as 400. And this is 600. Ooh, but I just noticed something. This and this are the same. Now, if that whisker and that whisker are the same, that must be 400. Well, that's a very useful idea because that should make finding this green hypotenuse a bit easier. So I'm going to say green plus pink plus, what do we got here? 400 plus 600 plus 400. Yeah, I think that would give me the perimeter. Question is, can you work out the missing bits? Now, let's be careful. The pink bit could get confusing. So if I want the circumference of a circle, I go diameter times pi, or I go 2 pi r. Since I've got the diameter, I'm going to go 600 times pi, or 600 pi. But I want half of that for half the circumference. So I'm going to go, this over here is going to be 600 pi divided by 2. So 600 pi would be divided by 2. Give me a thumbs up if you understand why I'm going 600 pi divided by 2. Okay, I need someone to help me with my Pythagoras now as well. We'll call this x. X squared, we'll go x is equal to 400 squared plus 400 squared square rooted by Pythag. Can a friendly face help me out with the green distance here? What's this distance over here going to be? Anyone? I can do it myself too, but so 400 squared, well, let's go square root 400 squared plus 400. All right. What is everyone getting? Are you getting 565.69? Okay, so now to get the final perimeter, we need to add up all these values. So we are going to add up 1,400 for this bit over here, plus 300 times pi divided by 2, plus 565.69. What is the final answer that you are getting for the perimeter? Hi, Bukle. What is your question?
So I wanted to ask, for calculating the perimeter of the square, why did we leave 600 out? Because it's not 2L plus 2B, isn't it?
Okay, so let's have a look. Let's check. I might have made a mistake. Are you happy that there's a 400 here, which I've just done? So there's 400.
Yes, sir.
Okay, then there's this 600, which is here. Then there's this 400, which is here. So I've dealt with those ones. Now, the only other bit that's left is the green thing here, and then the pink bit, like over here. So I don't think I've left anything out.
Oh, so that's 600 there by the diameter of the semicircle. We leave that one out.
Yeah, because it's not on the outside. The perimeter is only on the outside. Yeah.
Okay. All right, I understand. Thanks, sir.
Perfect. Thank you for your question. Okay, what are we getting? I'm getting 2,436. Is anybody else getting that? I can do it again just in case. 1,400 takes care of this stuff. So 1,400 takes care of that stuff. Plus, I could say 300 pi, I guess is another way of saying that. Plus 565.69. Oh, I get 298. 2908. Sorry, I made a mistake. That was my boo-boo. 2908.17 meters. Who is with me and Naledi on 2908.17? Thank you, Naledi. You kept me on the straight and narrow there. Okay, one more. Let's go. Find me the area. Find me the area of the shape here. I want you to find the area of this interesting looking shape. So find me the area of this interesting looking shape here. I would suggest visually it looks something like that, but you still need to go and find me the values. Okay, so what about this first bit? I think it's pi r squared divided by 2. And look how nicely it fits if I just leave a space there. But the radius is 300. So that takes care of that bit. Now you need to find me the next two parts and then give me a final answer. How are we going to get the area over here? Oh, that's just going to be 400 times 600 because it's a rectangle. So that's okay. And now I need the area of this bit. Oh, but I just go a half base times height. But the base and the height are both 400. So what is my final answer? I'm going to have to plug this into my calculator. Okay, I've got a final answer, but I want someone else to put their answer down first before I put mine in. The lady, you're on fire. You're on fire. 461,371.6. Okay, so 669 would round off to 67. And this would be meters squared. So 461,371.67 meters squared. The reason it's meters squared now is this question was in meters. And I see Asande and Bukle, Callan are backing us up there. Fantastic. Okay, so what have we done today so far? We've really just made sure we are comfortable with perimeter and area. But where are we going to go in the next lesson? I'm going to give you a little preview now. So we are going to talk about surface area and volume of three-dimensional shapes. So what are the three-dimensional shapes that we need to start to think about? Well, we have something called a cylinder. And a cylinder has like a circle on the top and then a circle on the bottom. And then it has this funny bit over here. Does anybody know what this funny bit, when you unwrap it, ends up being? Just out of curiosity. It's a rectangle, yes. So when you unwrap this, the lateral surface area, you can think of a cylinder as basically a circle plus a rectangle. And that's a useful thing for surface area. And if you think of it in terms of volume, it's just a whole bunch of circles that are stacked on top of each other. Then the other thing we need to get comfortable with is something like a triangular prism. So let's see what that looks like. It's like two triangles that are just connected. So I think of it as like Toblerone. And when we think of this shape, we have like a rectangle at the bottom. We have another rectangle over there. And then we have a rectangle in front. And then we have a triangle over here and a triangle at the back. So that's a triangular prism, but we can also have what's called a square prism or rectangular prism, in which case we just think of it as these three matching sides that look something like that. And then the bottom one I'm going to say is red, and then over here. So we need to get more comfortable with this shape. We also need to get comfortable in the next lesson with what if I, instead of drawing a whole cylinder, maybe I draw a half cylinder. And so, how do the formulas change? That wasn't actually a very good drawing, but I'll, imagine if I chopped it in half going down here and I got rid of the one side, how would that work? So that's where we're going to go in the next lesson, and we're really going to talk about surface area and volume of the shape. And then after that, we are going to talk about some other shapes for grade 11. So things like maybe like a pyramid. So something like, something like this. So we can talk about things like a pyramid, or we can also talk about a sphere. Like a sphere is like a circle that looks a bit like that. And in terms of, that's also a three-dimensional shape that we need to talk about. I'm trying to think, what are the other ones? Oh, we need to talk about things like a cone. So we also have, this would be an example of a cone. And so these are shapes that we'll talk about in future lessons. Okay, everyone, give me a sense of how you are feeling with a score out of 10. How are you feeling about measurement so far? Where 0 is 5 is 10, and these are our emoticons that we have to help us. Where are you on the scale? Okay, so we're just starting with measurement, so don't worry if it felt like I went a bit fast today. We will build on top of this each week that we do measurement. All right, now, what we're going to do now is, it's the end of the regular lesson, but I am going to do one question quite quickly from student questions. So there was a question that was submitted about functions. And so what I'm going to say is I'm going to give you a 2-minute break. So I'm not going to turn the screen off, but I'm going to step away for 2 minutes. Let's make it, I'm going to come back online. Let's make it 4 minutes. At 18:35, I'm going to come back online and start looking at this problem on functions. If you've got the time, hang around and I will quickly work through this question, which was a student question that was submitted. It might be a bit on the quick side, but you can always watch it on the recording. But yeah. Okay, so I'll be back in 3 minutes when we'll work through this functions question. But if you need to go, then I totally understand, and give me a wave as you leave the lesson today. Thank you so much for coming. I really appreciate it. All right. Bye, Bukle. We don't have to do this question, but I thought it was submitted by students. So if there are any students who would like to me to work through it, I will start working through it. I'm just going to wait another minute. So I see we still have, Sunday, Callan, Ganlin, Machidiso, Pabalelo, Busile. Now remember, guys, we might not have time to do this whole question, but I really want to encourage you to submit your questions, especially as we get towards the end of the year. I know many of you have sections maybe that you struggle with, and it's a chance to just allow you to dictate what we cover. Okay, we're going to start shortly, but while I'm waiting, this is hyperbola standard form. The question is based around this hyperbola. So maybe have a moment, just look at this while we wait and read the question. Okay, maybe what I'll do is let me just do 6.1 for now, and then maybe I can do 6.2 in a future lesson, depending on how it goes. Okay, give me a thumbs up if you're ready to start the functions question. Okay, question number 1. The equations of the asymptotes of f. Well, what are the asymptotes? This is called the vertical asymptote, the green one. And this over here, let me use blue, this would be called the horizontal asymptote. Now, in order to know what these are, let's have a look. So we probably need to work out what is the equation. Does it tell us any other information here? So it says C and D are the intercepts. Okay, so we know we've kind of got this thing that we need to work out. X plus P plus Q. We've got 2 points. Oh, you know what it is? Here's the magic point. This point over here is going to tell us what's going on, B. So what we know is that this must be -4 over here, and this must be -3 over there, just from using this point over there. So the equation of the horizontal asymptote is going to be y equals -4, and the vertical asymptote is going to be x is -3. Give me a thumbs up if you follow that. Okay, now 6.1.2. What is the range of f? So the range just concerns the y values that are all allowed, and all of the y values are allowed except the y value is not allowed to cross this line. Or it's not allowed to hit that line, which is -4. So all we write is y can be any real number, but it cannot be -4. So that one is that one over there. Okay, now, thumbs up if you got that. Okay, now the next one, the domain of x plus 3. Okay, what does it mean when I say f of x plus 3? This is what's called a horizontal shift. Okay, and it's a horizontal shift 3 units to the left. So when we deal with horizontal shifts, they actually work the opposite way around. And so this whole graph, the domain of f of x plus 3 is saying, what is the domain of a new function which shifts the graph here 3 units to the left? Now, if we shift 3 units to the left, this line over here is going to have to go 3 units to the left. What do you think this new dotted red line is going to be? It's going to be x is equal to something, that new dotted line. Yeah, because it was at -3, so now it's going to be x is -6. So the difficult part is understanding what that actually means. And it means to shift 3 units to the left. So now, if I go 6.1.3, I'm going to say for this new function, x can be any real number, but x cannot be -6, because the new function would basically look kind of like that. And so that would be the x value excluded. Give me a thumbs up if that made sense. Thumbs down if I lost you. You can also rewatch the recording. Okay, well, while we're doing all right, why don't we have a quick crack at finding the numerical values of k, p, and q. Now, where have we seen that before? Well, that's actually just the standard form, right? That's actually just the standard form of this hyperbola. So if we could do y is equal to k over x plus P plus Q, they are basically saying, what is this? What is this? What is that? And the green and the blue one are actually quite simple. So all you need to do for the blue one is look at what is the blue line here. It goes through -4, so this is going to be -4. The K we don't know, but this basically comes from where is the horizontal asymptote. Now over here, I'm going to have, I need to make -3 undefined. So this is going to be x plus 3. So the way I tell students is to think, what value would make division by 0 occur? What x value do you need to put here? And the only x value that you could put here to make it undefined would be -3. And this makes sense because in the original function, this thing is going through -3. Okay, now that was a bit quick, but you can go over it in your own time. What do you think I do to find the value of k? What information have I not used that maybe I can use to help me? Who has some ideas? I think at the very beginning, they gave us -3 and -4, which we've used, but there was another point called A. And A was the point -1, -5. So I'm going to sub that point A into this thing. So I'm going to go -5 equals K over, what was this? Let me assume thing for a moment. -1 plus 3 minus 4. Okay, for the last question today, I'm going to say find K. And then in the next lesson, I will pick up with the second half of this functions question. What do you think the value of K is going to be? I need to get this value here by itself. What do you think K is going to be in the end? Can we do 6.3? We can do 6.3. Yep. Okay, well, to do 6.3, I can go through this if you've got the time. Okay, everyone, are we happy that K is -2? Okay, fantastic. So now we have got, let's just write this down. We have got the form y equals -2 over x plus 3 minus 4 is the equation of this hyperbola. So actually, you know what? I will do the whole question, but I might be going a bit fast. So you might have to do this in your own time or watch the video recording. Okay, now 6.2.2. Let's find the y-intercept of this graph f. Well, to find the y-intercept, we make x naught. So in that case, I get -2 over naught plus 3 minus 4, which is just going to be -2 over 3 minus 4, which is -4 2/3. So that is the y-intercept. To find the x-intercept, okay, let's find the x-intercept. Did they tell us what the x-intercept was? No. So the x-intercept, you would have to make y equal to 0. And if you make y equal to 0, you have to solve this equation. So now I'm going to take that and I'm going to say, 4 is equal to minus 2 over x plus 3. And then I'm going to bring the x plus 3. So I'm going to go 4 times x plus 3 is minus 2. And then I'm going to bring the 4 across and get minus 2 over 4, which is minus a half. And then if I add 3, take away 3. So I have minus a half, take away 3. I get minus 3.5. So the x-intercept is minus 3.5. Now that was super quick, but can I just get a thumbs up if you generally followed how I found those intercepts? Okay, now I'm going to skip 6.2.4 for now, but I will tell you how I would do it. Find the equation of the axis of symmetry that has a negative gradient. What they are referring to is the axis of symmetry would go like that. And so they want to say, can you find the equation of that straight line? And the gradient of that would just be it's basically going to be minus x plus c. And all you need to do is take this point over here, which is the point minus 3 minus 4, and put it into that equation to figure out what the equation of the pink line is. So that would be the process. Okay, now to answer this question about where is f of x greater than or equal to 0. So this just means where is the function f, where is y greater than or equal to 0. Now, for which x values, so that's important too, for which x values is y greater than or equal to 0? Well, for me, can you see this part over here? This is the only part where I see that the graph is above the horizontal axis. Can you see that that's the only part where the hyperbola is above that? Give me a thumbs up if you follow that. So that is what they're asking for, but they're not asking for those values. They're asking for the x values over here. Now, it would be very helpful if we knew what c was, but c is the x-intercept. So we know that c is minus 3.5 naught. So if I want, and do I know what this asymptote is? I know that that line is, that's minus 3. So that's minus 3, that's minus 3.5. So which x values are relevant? It's just going to be, now it says greater than or equal to. So this is going to be like this. And it should be a minus. So x must be less than minus 3. And the reason it excludes equal to is there's an asymptote here. But on the other side, there's no asymptote, and there is an equals to sign here. And so the answer would be x is less than minus 3, but greater than minus 3.5. And then for 6.3.2, where is it less than 0? Well, it's going to have to be all the other places. So basically, what is left? It's going to be the x values over here and the x values over there. So how would I describe that? I would say it's when x is less than negative 3.5, or x is greater than minus 3. So for 6.3.2, it's basically the green bits on the drawing. And the answer for 6.3.1 is the yellow bits over here. Now, I went super fast there, but my goal was just to give you a sense of how I would do it, and you could rewatch. So just give me a thumbs up if that sort of made sense, what I was doing at the end there.